Hello, my name's nigelargriffiths. I work in Power Systems Advanced Technology in Europe. In this movie, we'll be looking at getting started with PowerSC, that's the security and compliance of the power machines, and one of the 7 modules currently available called Trusted Boot. This first came out in November 2012. There is a particular class of virus attack called a Rootkit attack. We've already seen this on sort of PC equipment, and so this PowerSC Trusted Boot is to make sure that we're ready for this sort of attack for servers. We've not actually seen this out in the wild, but we're ready for it if it ever happens. The problem with the Rootkit attack is that it starts up with the operating system. In fact, before the operating system gets going, it can plug itself into the hardware interrupt vectors so that it can get called, say, once every 100th of a second. And it can fiddle about with the virtual memory in the machine so that the actual kernel can't see the memory in which it's sitting, so it cannot detect this thing. So what we want is some software that will say, has something or somebody been fiddling with our boot images, and if they haven't, then we know it can be trusted. If it was changed, there is a chance that it was us doing regular admin work, like updating our boot images. So we can say those are okay, but the rest of them we know then somebody unknown has been fiddling with these images, and we need to investigate that. So this is what Trusted Boot does for the power machines. In this session we're going to look at how to get started, how to monitor it and notice changes, and testing that it actually works. We now have at IBMcom a nice website that covers PowerSC and the modules that you can find therein. A very high level view, it gives you lots of features and benefits, but I found it a little bit frustrating when you say, well, how does it actually work? What do I actually need to do? What are the prereqs I need before I can get started? So this is where this video comes into play. So what do we need to get going? Well, we need the Power 7 machine, a C model or later. We already have the D models out when I'm making this movie. We're actually looking for anything that supports firmware 740 or above. That includes the Power 7 Plus machines that we have now. AIX, well, we have this version of AIX as the minimum, and we actually have a new TL out after that. And we have VO Server 2222 is actually out now as well. As far as I'm aware, there's no Linux or IBM I support at the moment, so this is just for AIX and the virtual I/O server. And the place to go for the documentation is down in here, PowerSC. I like the PDF because then I can page through it back and forth to look at the documentation rather than flipping between web pages all the time. So here's our Trusted Boot architecture. At the bottom of this diagram we have the hypervisor, and it has one of these things called a Virtual Trusted Platform module. This is sort of an open standard that we're conforming to. Built into the hypervisor, there's one of these for each logical partition or virtual machine. When our logical partition starts up, it's going through the firmware that extracts the details of the CPU, the memory, and the adapters and the disks. And it takes all that together and it encrypts that data and puts it into the VTPM. Then it says, okay, now I'm going to boot off this first disk. Let's go and encrypt the loader information. Then we'll encrypt the boot image information. Then we'll encrypt the copy of AIX that it's going to boot up. And as it goes through each of these processes, it collects some data, maybe a sum check or something like that, and encrypts it and puts it into the VTPM. And eventually we start up AIX. Now, at some point later, we run this piece of software called OpenPTS. This is an open source project, and IBM takes that and compiles that to run under AIX, and we support the version that we supply, but it's open source otherwise. You then run this, and it connects to each of the logical partitions you told it about over SSH to keep it encrypted, and the copy of AIX can extract its VTPM details, and it supplies those to OpenPTS. OpenPTS then compares that with, I put sort of a database in inverted commas here, it's a few files which are encrypted, so you can't fiddle about with them, and then it will compare the known safe values of the encrypted keys with the new ones that have just been sent from the hardware or hypervisor. If they match, then it says, okay, this image that's running in this logical partition is exactly the same as last time it started up. If it finds there's a difference, though, it can immediately flag up saying, hang on, this feature has changed in this logical partition. And there's various things that we can actually do about that. Sometimes, perhaps we've upgraded AIX and we've updated the boot image, and so that's known. We know that that should have changed, and we've detected that. That is good. The new value is now the saved current value that we can say is a good image. If, however, something's hacked in here or somebody has changed something unexpectedly, then we have to put this logical partition into a worrying state. We need to escalate to investigate what has actually happened here. Now let's get started. I'm on the HMC here. We have a machine here called Indigo. I've selected it, brought up the pop down in here and looked at properties, and we have the properties coming up in here and the capabilities. And down the bottom in here we're looking for, you have to slide this bar downside, and we get the Virtual Trusted Platform module capable true. We're ready to go. This machine supports it. If we then go from capabilities to advanced and we select the Virtual Trusted Platform module, we'll see that there are 60 supported on this machine. I think this is consistent across all the various machines, and I've used 2 of them, and there's 58 still available. There's a fixed number of them in the machine. Now if you're creating a new logical partition in which to run a virtual machine, and we're in the Create LPAR wizard in here, we can see that on the initial panel, create a partition, we give it a name for our partition. Down the bottom there's a new item in here, that the virtual TPM capable, and we want to select that. This means we're allocating one of these data structures for this particular logical partition. If, however, you're already running it, and we take properties, we can go to the general, we can see that down in here, and click this. You will get an error message unless, as it says up here, that your logical partition is actually shut down. You can't change this while it's running. So you have to shut it down, make the change, and start it back up to allocate this resource and this security setting. Now if we turn our attention to the monitoring software, we need to run this trusted boot on a copy of AIX. It's going to use SSH to get the information. It's called OpenPTS, which stands for Open Platform Trusted Services, and it's not unique to IBM. You can go and have a look at it on SourceForge. Now mostly it's one command called OpenPTS, so it is fairly simple to actually use. There is quite a nice graphical user interface that runs under X Windows, and I recommend using that because it's much easier to deal with. Now assuming the VTPMs are available on all our LPARs, this is the process we go through to getting this all working. First of all, we need to install the collector agent on all the monitored AIX LPARs. Then we install the trusted boot viewer on a particular logical partition. We need to set up the SSH keys on both so that we can communicate without typing in lots of passwords. Then if you want to use the graphical user interface, I recommend using VNC, unless you've got native Windows on your workstation already. Then we're going to actually use the tool. We can use the command line Enroll so that the viewer understands about a new collector. Then we can do verify and display, or we can do both of those operations on the graphical user interface. Finally, I've got one slide on troubleshooting. So all this is very simple to do. For your logical partitions that are going to be monitored, you're going to put the collector software on it. This, of course, as a reminder, has to be a Power 7 or 7 Plus C or D models or later, and these versions of AIX 6 TL7 or AIX 7 TL1 or later. From the PowerSC media, we've purchased the PowerSC. We'll look for a package called PowerSC. This is the standard edition, and the VTPM module. From AIX media, you'll find the OpenPTS.collector. And you just use, I tend to use Smitty install P to go and add those. They take very little time. You normally have SSH already, but you'll actually find those on your AIX media if you haven't. Now for the Trusted Boot tool that you're going to install just once on the AIX LPAR, the viewer side, it's not actually documented what you need to run this on. It doesn't have to have the right firmware. We're just running some software in here that we use for monitoring. So I was actually using Power 6 machine, and we're going to use a recent copy of AIX 7. And I'm looking for the AIX 7 expansion pack CD, or you can download that if you want. And we're looking for this OpenPTS.verifier. You see some different uses of words in here, viewer and verifier. It's the same thing. And again, we need SSH. Very small, straightforward. Smitty install P, and off you go. Next thing you have to do is set up your SSH keys. It is a security tool after all. You want to do secure communications between the viewers and collectors. So again, in the documentation, this goes very, very clearly what to do. On the trusted boot tool, logical partition as root, you generate a key, and you get that in here. Copy that to the logical partitions where the collectors are running, perhaps in the /temp, and then we can create this directory if it's not already there, and then we put the extra keys into our authorization keys file. Takes a little bit of time if you've got lots of collectors you need to set up, but otherwise it's very simple to do. Now if you want to use the X Windows tools for the graphical user tools, then you're going to have to make up your own mind. This is just what I do on my machines in my computer room. We use VNC to give us access to X Windows. I get that from the puzzle.org website, as a friend of mine runs that, and there's a couple of prerequisites. In here I'm using the RPM or AIX here to install the type VNC. It also needs two libraries, zlib and libjpeg. It's installing those for us here. I then start it up and it says, hang on, you need a password to access this, and I set that in, and then it tells us that the Red 3 machine is on the first port, and we can actually see the VNC graphical user interface running here. Again, you may have other ways of getting to X Windows, or if you're not allowed to use X Windows at all, then you'll be using the command line. So we're all set up now. This is a reminder of my little setup. I have a Power 7 machine. It's a 710C model, and it's called Indigo, and the LPARs on there are Indigo 2, 3, and etc. And they're running this version of AX7, and my OpenPTS is running on AX7, but it's actually a Power 6 machine. Let's go and use it then. On the viewer LPAR, we have the OpenPTS command, and it gives you a quick hint on how to use it. Enroll is -I. Why it's I and E, we don't know, but there we are. We use -V, that goes and compares the current status of all the encryption keys with what we have in our little database, and -D displays what's going on with all our logical partitions. Now it's quicker actually to go and do it than try and describe it. Let's just use OpenPTS -I, and for our two logical partitions, and that connects them up so that we're happy that we're in control now. If an SSH is not right, then it starts asking for passwords. You know you've got to go and double check your settings there. Now let's verify a particular logical partition, our Indigo 2 in here, and we get lots of stuff coming back that I have no idea what it really means, with lots of hexadecimal numbers. Very fascinating. The thing we're looking for is integrity valid. Then the saved one and what we just got back is the same. I then went and did a boss boot on this logical partition, Indigo 2. Changed the boot image, so we expect it to be able to detect this. And yes, it does. When it comes back, it says, okay, we got a valid thing back, but it doesn't match what we have in our encrypted database. And do you accept that this change is good? So yes, you'd say it's okay, it's expected, and the new encrypted key is good. If it's unexpected, then you have to start asking around, okay, who changed Indigo 2? Do we have a good explanation for why this happened right now? If we can't find a reason for this LPAR changing, then we have an unauthorized change to this logical partition. And then the third option, the -D, tells us about the configuration. It lists our particular host down in here, a whole load of other information about the machine it's talking to as well. Well, that's about it for the command line. Let's have a look at the graphical user interface, which I found a bit easier to use. So here's my X Windows starting up. In one window here, I've typed in this big long command, opt IBM OpenPTS GUI, OpenPTS GUI. I don't like the shouting, .shut, and it pops up, looks like this. If we click on welcome and then enroll, we get things like this. So we get a nice little explanation of what's going on. And when we do an enroll, here's my Indigo 2. Then I type in the user that it's going to use for the SSH connection, because it may not be root user, and then add an enroll. My first time in here, I actually had problems with SSH, all down to me, and instead of enrolling them, they went into this not enrolled state in here, and I looked in the window in which I started the application, and it was started to ask me about authentication keys and asking me for more passwords. Clearly SSH wasn't connected up right. I had to go off and fix that. When I did that, I then found that my machines went in properly into the trusted state, and everything looks good. I then tried causing some problems and making sure that we could detect them. First one was I ran the boss boot command. That changed the boot image, and it was detected after a little while. So it goes into the update pending. So it says this has been changed. You have to decide what do you want to do. And if you then click on this particular machine, Indigo 3, and then say accept, it gives you a little pop-up, are you sure? And you click OK. I then generated another problem. What happens if OpenPTS can't talk to the client, the collector? Well, I just took the network down on the logical partition, and then after about a minute it notices that the SSH connection has gone and puts us into the error state. I then went to the logical partition and brought the network back up, pretending that there's some sort of network outage. And then I go up here, file and refresh. It then tries again to connect to everything, and it says, okay, yep, he's still in the same state. We've got the valid encryption keys, and we're back into the trusted state. That's pretty good. Now I really like this refresh option. It's the same as using the OpenPTS -v command, but you have to run that on all of the collectors, all the LPARs you're connected to. There's no way of doing that to the whole, but then you could write a script. You collect the output of OpenPTS -d, pick out the host names, and then use that to drive through the OpenPTS -v. But then if there was a problem, it's going to ask you a yes-no question, so we're echoing a no in here, so it won't change it. So here we say Indigo 2 is valid, Indigo 3 had a problem, it'll answer no and carry on, and then you'll look on your screen to find the ones that need some actions. In the PowerSC documentation, there's a very useful table that I found. There's table 4 about page 16. That told me a whole bunch of things that PowerSC Trusted Boot is checking that I wasn't aware of otherwise. For example, the attestation. What a horrible word. It uses attest as a word instead of check that we used to. It looks like some legal word to me, but there we go. So perhaps it's trying to check, and maybe there's a problem with the network and it didn't come back to it. If somebody's changed the firmware on the machine, the actual kek, then that's highlighted. If resources allocated to their LPAR has changed, perhaps every time you're booting it up, it's using less CPU and less memory or something. Some hacker could be mucking about with your profiles, and so making your machine run slower and slower, and you've got to work out what's going on. It's a sort of very aggravated way of attacking your system. The firmware has changed on the adapters. Maybe they're trying to do something very tricky there. At least you should be aware that somebody's doing that. The list of devices connected to the LPAR has changed. Perhaps they're adding in a new disk drive and going to boot off that, so then try and access your data in a sort of offline mode. Number 6, your boot image changed. Typically this is an operating system upgrade, but again it could be a way of getting a special kernel to boot. The LPAR is booted from a different device. Perhaps they booted to the SMS menus, and again in there all sorts of things could happen to your system for a hacker trying to get in. Or that the trusted execution database has been altered. This is the viewer copy of all the encrypted keys. Perhaps somebody's trying to hack that end and hide the fact that they've actually made changes to your system. Now, I haven't been checking my machines regularly, and I come back to them and I find my OpenPTS reporting error status for my 2 logical partitions here. Then I thought, well, let's go ping those logical partitions, and they both refuse to ping, and I just noticed that they're actually switched off at the moment. So let me go to my HMC and come back when I've got those LPARs running. Okay, I'm back. My servers have been up for a minute or two now. Let's select one of these and we'll do the check or attest. Well, I didn't like that, so let's try force re-enroll. Maybe my security certificates are out of date. Okay, so it was an SSH problem rather than the actual virtual trusted platform module. Again, let's go in here, let's go and do a quick check. It doesn't like that. And we'll force the SSH to go and reconnect. And we're okay. We're back to 2 trusted in here. I particularly like the button up here for the refresh. If I had 400 or 500 in here, it would then go around checking all of them, and the ones that I had problems with would appear in anything but the trusted bucket in here. I could click on here to go and investigate what was happening and whether it was an update I knew about or not. So as a summary then, simple to implement and understand once you've got the basics. It alerts you when boot images or boot sequences have changed. If it's an expected change, then you'll OK that. If not, of course, this is where you get the problem. You have to do something, don't you? You have to ask who's been doing what, start looking at your logs if nobody confesses to what's going on, and eventually you'll have to decide that you have had a hack attempt in here and have to do something about it. The alternative, of course, is that it doesn't actually report anything because nobody's actually trying this low-level hack of your servers, and it gives you a great deal of confidence that you're actually in control of your machines.